Welcome to the Trino Community Broadcast.
Cool. It has been a while.
It really has been, Manfred.
Huh?
It's our first Trino Community Broadcast of 2025.
Yes. Crazy. Like it's been like November or whenever we did the last one. I don't even remember.
Yeah, we've got a lot to catch up on that's been going on since the last time we talked. I think we were still hyping up Trino Summit being upcoming during that episode.
And that was awesome and you missed it. Boo-hoo.
I watched I think 60% of the sessions live, so.
Yeah, no, we'll talk about that more. It was super awesome. But we are very honored today to have one of the Trino co-creators and master hackers join us today. David, thanks to join us for the Trino Community Broadcast. It's awesome to have you on board, and maybe you can educate us a little bit again today, as usual.
Thanks, Manfred. Happy to be here.
Yeah, we'll talk about a whole bunch of things, but the first thing we're going to do is because we got a lot of releases in the pipeline. We just checked before, and it turns out that the 465 release was in November. And so since then, we shipped these 4 releases, and I might make this a little bit bigger. Can you read this now? Yeah.
Yeah, and these weren't light releases either. Like, these are some pretty big high-level highlights.
Yeah, there's some heavy stuff in there, including what we're going to talk about later, the Year of the Snake and Pythons and all sorts of jazz, but more about that later. Let's talk first about 465. So 465, as usual, we did some stuff on Iceberg, so we have this extra properties support now. We have some more stuff in the Faker connector. By the way, Jan, props, that connector has been rocking. It's really useful to create sort of like artificial data on the fly in the memory, and that's really good for like trying things out and like starting up a Trino and then do whatever without any headache for storage or anything. Similar to the memory connector, but it can synthesize data. So very nice little project that has been going pretty well. And then the customer provided SSE key for the S3 file system is also coming in or came in 465. David, the S3 file system in general, the file system support has been going really well, I think. You as the file system lead, what's your perspective on there? Are we going to remove some of that legacy stuff pretty soon, like sometime in 2025?
Yeah, I think 2025 will be the year that we remove the legacy ones, especially like the legacy S3 one, which is probably the most used legacy file system. It uses the deprecated AWS V1 SDK. So we're actually under Amazon's timeline there to get rid of it before it's completely like out of support.
Yeah, well, the good thing is that users can already switch and have been able to switch for quite a while. And the new file system that you created is faster, more stable, easier to implement, and really awesome. So there's no reason to stay behind, people.
Yeah, that's right. Start using it. If you run into any issues, let us know.
Exactly. And then, and for those of you that don't know, this is in the Trino documentation. You can go to object storage and look at the native file system support. And there is Azure, Google Cloud, S3, and Alluxio here as native file systems that are supported. And the docs has all the details. Now, moving on to 466. We are touching the snake the first time here. In fact, we removed the requirement for the snake in this case. So Python used to be a requirement for running Trino, and that's a headache because why, Cole?
Because Python versioning is kind of a mess. I don't know like how many people have the struggle of having UV or PyEnv with like 17 different Python versions to get all your requirements, but it's pretty common in data engineering land. And one less thing using one less specific version of Python is a boon for sure.
Yeah, and also on Trino, it was even more of a boon because now you don't need to install it anymore on your Trino cluster server. So get rid of that headache, allowed us to remove the actual requirement, which allowed us to remove a whole bunch of potential security issues. So now we have a launcher script that was kindly donated by engineers at Starburst, and it's written in Go. And a lot of us have no idea how that works, but it works. Not a massive thing that came in thanks to a lot of work from Mateusz and David and others is the client protocol improvements with the spooling mode that is now stable. And also news about that from I want to say 2 days ago, the Trino Python client release now also has support for the spooling protocol. So now we have the JDBC driver and the Python client supporting the spooling protocol. More to come on the other clients.
And spooling is like our kind of spill to disk functionality.
No, it's not. It's kind of like, and there will be an episode on the 30th of January with Mateusz himself talking about all the details. So Cole, you're gonna either have to be a co-host to ask questions then, or you're gonna have to be in the audience and ask via YouTube and LinkedIn. But in a nutshell, spooling protocol, instead of the coordinator sending you all the data, the coordinator and the workers dump the data of your result sets on object storage. And then the coordinator can say, oh, we're done here. And your client tool can go to the object storage and load everything in parallel. And the workers can write in parallel and so on. So massive improvement for queries that dump a lot of data onto the client, right? Like for a little select top 3 from blah, it's not going to do a difference. But if you have thousands and thousands or even more rows, then that's a big improvement. So very good. And obviously that's useful for people that do analytics on the client, AI and whatever, right? Like if you suck
when you start selecting gigabytes worth of data getting returned, that is pretty handy. So
yeah, so really cool. Another thing that shipped in 466, which was really amazing, is we have access control with Apache Ranger finally in Trino itself, which makes it much easier for all the users that use Trino and Ranger together, because they don't have to make it work for whatever specific Trino version they're going to use, because the SPI changes and it's complicated. And that's being now available, and it includes things like pretty cool features like column masking, row filtering, audit logging. So that was a very long effort. The plugin has existed in other places before, but it is now in Trino, and that's awesome. So really cool. So that was 466. 467, we changed the default internal communication back to HTTP1 because we found some issues. We're still working on fixing that and going back to HTTP2. We removed the micro-DNF package manager from the Docker image, so even smaller Docker image. Now no Python and no packaging at all. That doesn't mean you can't install stuff and you can still do your custom Docker image, but it makes the default better. We now have an all manifest. Pardon?
Smaller and more secure.
Yeah, exactly. Yeah. The event listeners now support open telemetry tracing, which is really useful. We had an episode about open telemetry actually with David as well in the past, and Matt Stevenson as well, which was really awesome. And I'm still trying to get the documentation for all that done, especially the open metrics part. But the PI is getting really close, so stay tuned for that. And if you want to use open metrics, look at my in-progress PR somewhere on Trino GitHub. We got the new all manifests metadata table in the Iceberg connector, and we also have the transactions metadata table in a Delta Lake connector. By the way, on the 469 release that's coming, we have docs for this all manifest table now, and we also have more metadata tables like all entries and more stuff.
And so this allows you to access, read, and look at all your manifest files that are within Iceberg. Is that what it does?
Yeah, exactly. Yeah.
Okay,
it's
that's pretty handy.
There's this a massive collection of metadata underneath the hood of any specific table, and there's a whole bunch of dollar blah 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 metadata tables associated to each table that allows you to inspect all that stuff. And that's just another one of them.
It's what I want to do with that is run query all manifests, expire snapshots, query it again, and see how much I saved. That'll be
cool. You can do a lot of that. There was a good talk from, was it Kevin? I think Kevin Liu did a Trino community broadcast. Oh no, Trino Summit talk or something about basically making analytics with SQL queries on all those metadata tables to understand your storage and stuff on Iceberg, which is pretty easy then, because then you can use your BI tool to like visualize all that, and you don't have to hack around with PyIceberg or some scripting hackery. So that's really cool. And then in 468, David, we got your Python user-defined functions in, which was really cool, and we'll see lots more about that. We also renamed our old SQL routines to SQL user-defined functions to be more consistent and encapsulating. We got a cluster overview to the preview web UI, which is starting to become usable. We just merged authentication support for it recently. That's going to come in the next release. And then we also have the merge statement support for the PostgreSQL connector, which, by the way, is slowly bubbling across all the JDBC connectors. Forgot the contributor's name, but it's amazing how that contributor from China, I think it's Chen Yanusa, started implementing merge support on JDBC connectors in the base framework, added it to Ignite, and now it's going through one after the other. So props for that work. Very, very cool.
Before we dive into the user-defined functions, I have a question. Why were they SQL routines in the first place?
Because that's the name in the spec.
It's the ANSI SQL specification calls them routines instead of UDFs.
Yep.
Okay, and we went with that until we realized, well, if we're doing UDFs, we can just
Yeah.
Because every time I talked about them, I was like communicating SQL routines to people. I'd be like, yeah, Trino has UDFs. They're called routines, though. Was how I had to navigate that. So
yeah, now we're talking about the other way. Now we have SQL UDFs, and in the spec they're called routines.
Yeah,
so
okay.
it's like chicken, egg, hello. Yeah, so that's been cool. So that has been the releases. 469 is in the pipeline. We've been working on it for over a month already at this stage. There's a couple of blockers, a couple of tricky issues, and we're going to try to ship it really soon. But it's not out yet, so we're going to talk about that one in the next Trino Community Broadcast. And today, and for now, we're going to talk about some other things, and that are other news. Which one do you want to talk about, Cole?
I'm going to talk about Trino Summit because I actually paid attention to that a little more. You do the gateway.
Okay, so Trino Gateway, just quickly, we can't release Trino Gateway 13. Anyone here? Just a few little changes. There's lots more big changes coming. We have a whole bunch of PRs lined up, and we're working towards another release. Related to Trino Gateway, and also is a light over, we have a list of users now. So if anyone is using Trino Gateway, these are just the ones we know about and can tell you about. There's lots more users. But if you are using Trino Gateway somewhere, let us know. We'll plop you onto this page. And then on terms of the resources, we had this talk at Trino Summit, and there's the video recording and the slide deck. And otherwise, what happened at Trino Summit elsewise?
Yeah, so Trino Summit was, I think, the second largest Trino event ever. We had a ton of talks. It was our first time really opening it up to beginner talks as well as truly advanced talks. So
2 days was really awesome.
Yeah, wide range of topics, wide range of conversations. There was a panel on AI that was interesting for the people who are trying to ride the wave of AI. Tons of stuff on not AI for the people who are still building the kind of traditional, functional, let's just make it work type deal, which is kind of Trino's mantra, I feel. But, it's something for everyone and tons of insights. You have the stories we've seen in the past of migrating to Iceberg, like you're hovering over data lake at Wise powered by it. Strangler Fig Talk was also very interesting. That's just a design pattern I'd never heard of before. And it's a fascinating title, it catches your attention. But in any case, all of these videos are uploaded onto the Trino channel. We have the recap that you can see Manfred hovering over right now. There's something there if you're a Trino user. You will be able to learn something meaningful, improve your deployment, improve how you manage it, see if it's right for you if you're on the fence. It was a really great event, and the speaker lineup was really solid as well. So,
yeah, specifically also, I think a couple of exciting events I wanted to point out. So if you want to have your mind blown about scale, you need to look at the Netflix talk in terms of just the volume of data, the amount of Iceberg tables they have, and just the active users, 2,500 active users concurrently. And it's ridiculous. Heads off for that. We had others from Vice, FanDuel, Prezi. We had 2 presentations from LinkedIn. They have a really solid team working on that. Shouts out to them for all the work they're doing, also with text to SQL and other things. panel you mentioned. And then also the other thing I wanted to mention, we have another bank here again. The Helm chart improvements that Jan did with Sebastian are detailed in this presentation here. So if you're using Helm to deploy Trino, very useful. The Helm charts are really solid now. There's lots of cool stuff. Trino Gateway already mentioned. And then last but not least, also I think one of the coolest talks in my opinion, but I'm totally slanted because I've been working with George on this, was the last talk, and that was the one from George Fisher from Microsoft. They donated a C# and ADO.NET client library that they've been using internally for a long time, and we're working towards a release. So that's been super exciting to get to fruition and see that, and hopefully share that with everyone and get usage out there. He did a demo with, I forgot now. Is it called Unity, the game development framework?
Yeah, that's right.
Yeah, okay, Unity. I was just like, Unity, that's the catalog name.
It's both. it's a game engine, yeah.
Yeah, so that's a game engine that supports C#, and he did like a 3D visualization of this data that the client gets out of Trino, and that was just like really cool to see. So excited about that.
The truly massive companies who have the resources to like dedicate engineering teams to managing their Trino deployment and making it as like excellent as possible are always really fascinating. So like Netflix, LinkedIn, Microsoft being kind of at the forefront of managing these massive scale Trino operations are always cool to hear from.
Yeah, so it was a good event. We had like many hundred people live in the audience, and we're still taking up the views on YouTube. So take advantage of all that resources available here and let us know. And there will be another Trino event coming up later this year, of course. But now we should be switching over to our topic of the day, and that is user-defined functions in Trino. David, tell us more. How did this come about?
Yeah, so actually, I think I saw a tweet about the Chicory project, which is a WebAssembly runtime for the JVM. And then that gave me
like, what does a WebAssembly have to do with Python functions?
Yeah, so WebAssembly is this, fairly new technology. I think it's been in the works for around 8 to 10 years. Started at Mozilla, and like all the browser vendors adopted it. Basically, it's kind of like a CPU architecture, or like think of it like a platform for running native applications in a fully contained and sandboxed way. So like all the browsers support this. You can run Python or like Doom or like any kind of like native application that like is written in C or like a compiled language. It compiles down to WebAssembly, and then like you can run it in the browser, or you can run it on like various WebAssembly runtimes.
So is it like literally like a fake processor architecture that the C code is compiled to? So there's like a WebAssembly compiler thingy or something?
Yeah, you can think of it kind of like a CPU architecture, like x86 or ARM. Like it's an alternative to that a C compiler compiles to. But beyond that, like you don't just have it's not just the CPU. It's also like a program has to like call system calls. So like if you compile a binary for Linux, it's going to be calling like the Linux kernel APIs, or like in Windows, it's calling the Windows APIs. So WebAssembly has its own system interface that programs call as well. And when you have a WebAssembly implementation, those calls are fully sandboxed. So like instead of talking to the file system, you're talking to this like virtualized implementation of it. And so then we have a implementation of that in Java. That's what Chicory implements. And then that lets us have Python running inside of the same JVM that Trino runs in a completely safe and sandboxed way.
So does that kind of make sense there? Like there's Python as a WebAssembly, Chicory is the kind of like handler, and that's all in Trino, which runs in Java, which runs in Linux.
Exactly. Yeah. So we take Python, real regular C Python. It's not like different implementation. It's the same Python that everybody uses. So it has all the same semantics and functions and everything. Compile it down to WebAssembly, and then that runs and actually gets Chicory, turns it into JVM bytecode. Then that runs inside the JVM. But it's not like Python running where it can talk to it can open up sockets or read random files or anything like that. It's all fully sandboxed within the JVM, so it's completely safe and secure. And so you can safely write Python functions inside of Trino, but you get so instead of writing them in SQL where it's a very limited language, you get all of Python. You can do anything you can do in regular Python, more or less you can do in our implementation.
So that's completely non-obvious, this approach. What made you think of doing it that way?
Yeah, so an alternative way to do it is you can set up Python externally and talk to it. Some people might run it say inside of AWS Lambda, or you set up these secure containers, with different types of sandboxing. But for and that works okay if you're building say a cloud service where you have full control over the stack and you can spend all your time. You can spend the time to set it up and to make sure it's secure. But just for the average Trino user, there's no way they're going to be able to set that up. So by doing this approach, it just works out of the box. It's actually shipped by default with Trino because we're completely confident in the security and reliability of it.
So and it's worth emphasizing, this is truly seamless. We were discussing, Python as a requirement just to install Trino is annoying but feasible. Running Python with Trino would have been more of a pain because if you're doing it in a container, you're going to need to connect and communicate, and that's going to have a lot of architecture involved in plugging and connecting those things in. You need an engineer to think long and hard about how to do that. Whereas with this, it just works.
Exactly. And you have to think about all the security and sandbox issues with that as well. And just provisioning and whatnot. Because we actually run a separate Python interpreter for each Trino thread that's running UDFs. So you can imagine you might need thousands of Python containers to do this in a more traditional way.
Yeah, that wouldn't be fun. Wow. So that sounds non-trivial. How non-trivial was it?
It was more than a 6-month project, off and on. A lot of the work was, a lot of the work, I contributed heavily to the Chicory project. I basically wrote the entire compiler from WebAssembly to JVM bytecode. Chicory also has an interpreter, but the interpreter can be several times slower because it's actually interpreting it versus it's compiling it. So when you compile the JVM bytecode, now the JVM can actually turn that into assembly for the target platform that you're running the JVM on. So you can effectively turn the Python and WebAssembly into actual native code, similar to what you would get out of a C compiler. Now it's not but it's it's fast enough.
So the whole thing is basically because everything runs within the JVM, everything is also having the benefit of garbage collection, tracing, and all that kind of stuff. You can understand what's going on to a large degree if you look into it, basically.
Yeah. So let's say you write a Python function with an infinite loop. We support interruptions. So just you can write very expensive functions in Trino, you could do expensive regular expressions or Lambda expressions or SQL functions. And Trino doesn't care, right? Or just you can write a SQL query that it's a cross join and it's, it could run for days or weeks, right? Because just massive amounts of data. The requirement that we have is that any code inside of Trino has to be interruptible so that if the user cancels the query, everything has to stop. And the Python implementation inside of Chicory is no exception to that. We guarantee that the WebAssembly code is fully interruptible, so it doesn't matter if you have an infinite loop or anything like that. If the user cancels a query, it's going to get interrupted. It's going to stop using resources.
Wow, that's impressive. Holy moly.
So
it cleans.
Let me get this straight. Step one was build the compiler and make it interruptible. That was where this project had to start. Okay.
Yeah. And then build out the system interface as well, implement all the file system functions and everything else that Python needs.
Manfred, I think non-trivial might be selling it a little short.
Is it fair to say that you're very good friends with the Chicory team now?
Yeah, those guys are great. There's like a weekly sync up, which actually Trino's been doing as well, like the contributor calls. Like it's actually nice to meet on Zoom and like talk in person every week about like the problems you're running into and just like where the project is going. So like Trickery has definitely evolved like quite a bit in like the past year since I've been involved. Like it actually, they just did a 1.0 release just like last month. So like it's finally like in a point where like it's stable, and like we'd recommend everyone to use it if you're interested in running native code inside of the JVM in a safe and secure way.
Yeah. So now you make me feel bad because you said they have a weekly meeting and we only have a monthly one. So I'm like, dang, I need to find more time in a day to do the weekly thing. Because we have a lot of contributors as well that want to have our help and like sync up with us and do more stuff. So yeah, well, maybe that's a like a plan for 2025 to up the sequence. But we do have one planned for later this month. In fact, I think it's the 23rd, so that's actually next week. But you can check the Trino events calendar for that.
But so getting back on track. Okay, so we have this understanding of this architecture where we're writing Python functions, compiling them to WebAssembly, turning them into Java bytecode, executing that in the JVM in a way that's safe in a container effectively, but within Trino. And then what can we do with that? Like the end thing for a user is we can go write Python and run it in Trino, right?
That's right. It's just like any kind of UDF you'd want to write. Like previously, like before we had the SQL UDFs, you had to write these in Java. So that was like a big deal. Most users don't want to write in Java. Plus, like you had to restart your cluster to add these functions. Like you had to write them securely. It was a big pain. Then we added SQL UDFs, which meant like any user could just do like create function or with function. And like that's all great, but it's like the standard SQL routine language from the spec. It's like kind of an oldish language from like, it's kind of got like a 1980s feel to it. And
yeah, we should show the readers. Hang on just a sec for the people that are watching. Let me find this. So we have the
it's definitely cumbersome.
User-defined functions here, and we have SQL user-defined and Python user. SQL user-defined functions has a lot of like useful pages. Let me change this a little bit. So if you go here, you see there's like the syntax is like begin case. Like this looks very like 1980s starting to program on my computer on like a Commodore 64 basic kind of thingy. Like that's what it looks like to me. And the examples are like that they show you. It literally like like this like. You could probably nearly run this on a Commodore 64 or something. But it's very basic, sort of like looking as a language. And now Python is very different, obviously.
Yeah, you could definitely like get some stuff done in it, but it's missing like, it's not Python, or like any kind of modern language where, like you can do loops and you can set some variables, right? But like it doesn't have any like built-in like arrays or hash maps. Like you can't really use those. So yeah, like the Python stuff is far more functionality and like much more approachable.
Yeah, even when you introduced this, like when we originally wrote that, I was like I started helping you with the documentation, and like it was like language, and then like the only choice for language is SQL, and like you were hinting at like, well, but we want to do more, so we're adding it to the language now, and I guess we're at this stage now where there's more. So heads off for thinking towards the future, and which is now the present, which is really cool. So
yeah, we did the SQL one originally because it was in the spec, and like it's a SQL language, so we kind of already had like part of the compiler for it. We could compile SQL expressions. You could call the regular SQL functions. You don't have to deal with type mapping, which is a problem with any kind of like language or like connector where like Trino has SQL data types, and then like your function, right? Well, like Python has like has its own data types, and you got to map to and from. With the SQL language, you don't have to worry about that. So like that's one of the benefits of it. And we could also do it like we wrote our own compiler, so it was fully sandboxed and secure as well. And we wanted to do something like Python for a while, but just didn't really see a good way to do it.
Yeah, and I think like even like this has been a year in the making. Like this has been a year out now. Like the the SQL user-defined functions are, and we have the catalog functions and the inline functions. I think this is super useful. Like even when we just introduced it with that, like if you compared that to having to write a plugin in Java and stuff like that, and all the deployment headaches, this is like a game changer. And it was, I'm sure, a game changer for many users. So having this create function, drop function, show functions, and all that stuff, storing them in a catalog, in the like basically in the Hive meta store or like in memory or whatever, this has already been a game changer. Now Python is obviously another level of game changer. So tell us a bit more about like how this like looks here. Like this is like a very simple example from the docs, and we have more, but it looks kind of odd. Like what's this stuff here?
Yeah, you want to zoom in a little bit?
Yeah. How about this?
Yeah, so the first part of it, like the function line, you say function, Python UDF name, like the parameters and data types. That's the same for SQL functions. Like it's not specific to Python. You're declaring the name of the Trino function and the Trino parameters and data types. Then returned, you're saying what's the Trino data type that it's going to return. And obviously, language Python, we're saying implement this function is going to be implemented in Python. The with block, like that's similar to like with create table, where you can specify properties. So you're specifying properties specific to the language implementation. The Python only supports the handler property, which says what's the name of your Python function to call. So in this case, we're saying handler equals Python function because we did def Python function as the name of it. So the $2 signs, that's actually new syntax in Trino. Currently, it's limited just for functions, but we talked about like expanding that for anywhere you have a string. But this is called like dollar quoted strings, and it lets you. It's a different syntax for writing a string, so that you can use like single and double quotes inside the block of the string, because otherwise, like it would just be a huge pain to write Python functions otherwise.
Yeah, so basically the Trino like parser just goes, let's just ignore all this stuff for here and not try to attempt any parsing, because this is stuff I don't know nothing about.
And
right, yeah. So the only thing
yeah.
Oh, go ahead, Cole.
I was saying like this is like an easier way to like escape quotation marks in your code without like
exactly.
Yeah. I have two questions. So with this handler being Python function, does that mean like I can write multiple Python functions with like helper functions, and the handler is just my entry point into what I've embedded in my query?
Exactly. So inside that's just like a string block, and you can have multiple functions. You can have import statements. You can have like top level statements. Like it's actually a full Python module, and so you can paste in like your full, it could be 1,000-line Python module there.
Hang on.
And then the handler specifies which function to call.
Yeah, so here's like some live examples. Like here, for example, we have the and again make this like there's the usual super simple one where it's like just the answer, and here there's like the handler is the answer, right? And that's it. But then and this is here used as a what we call an inline function. So it's like cleared and used within the same call, the same query. And then otherwise, if you do a catalog function, so you have a catalog defined that has storage, like the memory connector in the catalog, then you can do this and it's stored, and then you can run it like with the path. But like, as you can see here, there's like, you can have this Boolean XOR, for example, so you can do imports, or in this here is like a bit more example, you can import another sum, and then this is exactly what you were talking about, Cole. Like we declare that reverse words is the call function that we want Trino to sort of invoke, which is actually that one. But we have these other two that are also in line.
Okay, and
exactly.
on catalog defined functions, like, because we don't want to gloss over that, that means that you can define the function on a Trino catalog, and that then persists for both you and other users querying that catalog, correct?
Yeah. And currently, the only connectors that support that are the memory connector. So that's in memory, super good for playing around. but not so good for restarting the cluster because then it's gone bye-bye. But otherwise, the Hive connector also supports it. So, and then it stores it in the associated meta store. And then it basically is persistent, right? So we want to still expand that to like have other catalogs to support that, but that's sort of on our to-do list.
Okay, so that's coming still. But in the meantime, you can still inline it no matter what connector you're using, yeah? Okay.
Yeah.
Exactly.
So if you want to go back to that last example, I'll point something out here that's important. So like I said, like this is a full Python module, and we create a separate Python interpreter for each Trino thread that's executing. So like the user, you don't have any control over how many threads we create. We'll create multiple threads per machine, and then you usually have many machines in a cluster running queries. But so you don't have to worry about like the Python code being multi-thread safe, because each one will get its own thread. But importantly, we only instantiate it once, and then the function might be called thousands of times or more. So where we say pattern equals re-compile, that's to compile a regular expression. We do that once because like that's a global variable in Python that will be run, so that will be initialized once when the module is imported, and then Trino will get reused every time that function is invoked. So compiling that regular expression can be expensive, but we only do it once when we import the module. And so like if you did that inside your function that's Trino calling, it would be much more expensive because it would happen every time. Whereas with doing it like this, do your expensive stuff up front as a global and then reuse it.
That's really smart. Cool. So that leads me to another question then. Like overall, what's the performance like?
I haven't done extensive benchmarks. I think it was around 10x slower than like regular C Python. But typically, like for the kind of stuff that we're going to be using this, it probably won't matter. Like usually the stuff you're going to be doing is fairly expensive anyway. So it all depends on your use case.
Yeah.
This is not snappy real-time analytics. This is sophisticated. SQL is not expressive enough. I need Python to truly slice into my data and get what I want to learn from it, which that can take an hour or two, and that's okay.
Right. Exactly.
Wow. So that's really amazing. So we obviously want people to try this out. So one thing that I want you to talk about a bit more is this.
Yeah, what is this module? How are we compiling a regular expression? Is that just regular expression module?
Oh yeah, this is just the standard Python regular expression module. So we support, like, this is regular C Python, so you get all the built-in functions, like minus a handful of them like that don't make sense, like the socket function or the HTTP client function or things like that. That would be like talking over the network or like calling into like operating system level stuff. And there's a list in the documentation of things that like aren't supported, but like any of the standard stuff that you would expect to work, like it's all there.
So you said they don't make sense, like networking and stuff, and they don't make sense because it's a sandbox that has no access to anything like that, right?
Exactly. Like administrators of the cluster wouldn't be happy if users can have it like talking to random
do a bit of Bitcoin mining on the side or something.
Exactly. Yeah.
And I'm assuming Python packages also do not function here. So you can't like go write and publish your own package and import that?
Not currently.
Okay.
I've actually got an open PR that adds like a number of like third-party packages. But the way this currently works is like they'd have to be like rebuilt into like Trino would have to be recompiled for this.
Okay.
So if people have a wish to have a certain package in there, they could tell us, and then we would assess and potentially have it in there generically for for new Trino releases, essentially to make it easier. But we probably wouldn't want to just take any random package.
I mean, frankly, right? It's once that PR is merged, you could just go add it yourself, and if we approve, like, wait for the next Trino release, and you're good to go.
Exactly. For a standard Python package in PyPy, that's pure Python. It should just be like a one-line change to add it to that list of modules.
And you're just going to need to justify its addition.
Yeah. But we're still working on how to compile like native code, or native third-party packages are actually a bit complicated due to how like Python and WASM work. So we have yet to figure that out.
Okay.
So if you really know like Python internals and are interested in helping, like please ping me. I'd love to collaborate.
There's a hot 0 people on the broadcast listening to that probably, because that's
Hey.
like very, very deep.
I bet you there's one person who will hear that, but they're going to watch this 3 weeks after it aired and they'll be like, oh, they figured it out already. Okay.
Yeah, if you're watching this later on YouTube, because we're going to blog post about it on the Chicory community and the Python community, we want you to help us.
Yeah. And it hasn't been solved yet, so go message David.
Yeah, so
Right.
that's really cool. So what's next, and what do we want people to do now? Like obviously try it out.
Yeah, try it out. Send us feedback. Like let us know let us know how well it works for you. Let us know if there's anything like you're missing or any problems you run into. Like let us know what kind of like native like third-party libraries you're like, oh yeah, I always use a third-party library, like it's indispensable. Like let us know about that. I mean, obviously things like NumPy, which are like fully native extensions, like we would like to figure out how to get that to work. So like if you're like an expert in Python internals, like love to talk to you about that.
Wouldn't that also be like you said, native code? Wouldn't that also potentially be very complicated, because it has to be cross-compiled to WASM, and if it's written in like whatever native code for a certain architecture, that might not necessarily be cross-compilable, right?
Yeah, you'd have to recompile it for WASM, which isn't that part's actually not a big deal. Because like the WebAssembly SDK, it's got like a version of Clang, so it's like a standard C++ compiler. Like that. I mean, like that's how the Python stuff works. There's a Docker image that basically downloads the WASM SDK, downloads Python, like does a build, like builds a bunch of other stuff and like packages all together. So there's kind of like a place where it's like, okay, like we built Python, now we need to compile NumPy and hook it in, and like it would go somewhere in that Docker file. But yeah, I wasn't able to get that to work.
Well, not yet anyway.
Yeah.
That's really amazing. So I just wanted to so for people that are interested, obviously we have Python, WebAssembly, Chicory, Trino use defined function. I'll get the docs linked here. But I just remembered there's a separate GitHub project that you were also working on, and that's the Trino WASM Python. Like, tell us a bit about what. Sorry, one letter messed up. What is this about?
Yeah, so this is actually like the Python implementation that we're using. So it includes like a Docker image and build script to build everything for WASM. And then it includes I had to write a bunch of C code to actually integrate Python. So how it works is we effectively embed Python in a C program that ends up getting called by WASM as a library. And that it does all the translation between Trino types and Python types. So when you call you call your Python function with like say like a date, and it's got to translate into a Python like datetime object, invoke the Python code, and then if like say that code returns like a timestamp, now it's got to decode the Python timestamp object and turn it back into a Trino object. And so all that code is written in C there in this project.
Yeah, so that like types, that's maybe something worth talking about. So like in your example here, like for example, we have XOR. So here we have A Boolean, B Boolean, and then down here, it's like implied that it's Boolean, or how does the type mapping here work? And like what's like, can you maybe talk about some of the like pitfalls? Because I'm thinking type mapping is always a pain. I know it's a pain in our connectors and in our like underlying systems not supporting like the high date time precision that Trino has and stuff like that. So I'm sure there's a couple of like little traps built into here.
Yeah, there's actually the documentation for it. We have a table with the type mappings, but Python code, like Python doesn't have typing. I mean, there's actually like various like type hint projects, but that's the reason you don't see any types inside the Python code. But it actually does have types at runtime. So like if you declare that your function returns a Boolean for Trino, the Python function has to return like a Python Boolean that'll get converted back into a Trino Boolean. So the same is true like for all the data types. So it's kind of like up to the user to make sure that they match. And if they don't, you'll get an error at runtime.
So yeah, it's like with Python, right? It's typing is like, as a person writing Python code, not visible to you, but you can control it by being smart about how you write your code and understanding the Python internals. So that's there's probably some good tutorials out there about like what happens when you put an integer and a float and a string inside a dictionary. Like what type is that dictionary truly is one of those questions that you have to be aware of in these scenarios, because if you get it wrong, it's going to cause you problems. So
yeah. And there's things you can do, like that's a good example. Like you can return, like we support structures like arrays and maps in Trino, and those map to like Python like lists and dictionaries. But in Trino, everything has to be the same type. So like a list, like it all has to be big int or like varchar or something, right? You can't have a mix. Whereas in Python, like a list can have a mix of types, as you said. And so you have to make sure that like your Python object type matches the Trino type that you declared for the function. You have a similar issue actually like in JSON in Trino, because like in JSON, you can have an array of mixed types, but when you convert it back into Trino types, it has to be the same type.
Yeah, so that's the choice of computer science with strongly typed, static, and dynamic languages, and weakly typed, and all that jazz.
Yeah, and this is always going to happen anytime like a Java project meets a Python project, right? It's diametrically opposed philosophies on how typing should work, and you're going to have to play by the rules of the strictest thing in that system. So Java says, I want my types, and SQL says, I want my types. And so you're going to have to play nice with that and be cognizant of the fact that this is a pitfall. But I don't think it's that hard, especially in data. You know, it's relational data, even non-relational data is generally typed pretty consistently. So it shouldn't be that hard to work around unless you have a very messy back end.
Yeah. It's careful here, Cole. You don't want to start a flame war now.
I'm not saying one is right or wrong, just how it's going to be.
Yeah. So now that we have this infrastructure with like being able to run WASM and Python, we have like you can see how it's done for Python. Like this would be a way to support JavaScript or Ruby or like other languages that people want to run inside Trino. So I don't personally have any plans to work on those now, but like that would be an open project for somebody.
The
everyone's lining up.
Architecture and scaffolding are there. You just have to go reinterpret how to connect it to whatever language you like.
That's right.
Rust is going to show up at some point with the way things have been going, I'd bet, but we'll see who makes it happen.
Yeah.
All right, I have a shout out to Lester for appreciating talking about the Commodore 64. So hi Lester, thanks for being in our audience and chiming in. And then also a bit more importantly, Charmin is asking if you can have a table function with Python. So maybe can you explain what's the difference between a function and a table function? And then how does this relate to the Python user-defined functions?
Yeah, great question. So currently, like SQL functions and Python functions are limited to we only support scalar functions. So they take like a single value, or like one or more values in terms of like you call them with like arguments, and then they return a single value. Whereas like compare it to an aggregation function, which is called like many times, like with many values, and then returns a single value. And then a table function returns multiple rows. So effectively, like returns an object that looks like a table. It could be used like a table. We don't currently support that. So, but like that's something, that's something we could evolve the framework to support.
And to be clear, it's like the scalar function can operate on like a column by column, row by row basis where like you iterate over every row in a table, but like one row maps to one row as opposed to a table function where you can have X inputs mapped to this table of Y values and those two things don't need to be correlated.
Exactly. Yeah. Like a table function could accept a table and then return like completely transform it to a different type of table.
Might have to involve
something we'd like to support, but just work for somebody to do.
There's always more work.
Yeah, always interesting hackery to be done. All right. Well, that's been super interesting. Anything else we want to do here around this? Like, obviously, I think the advantages are it's completely encapsulated, it's secure, it's pretty performant. Deployment is essentially a no-brainer. Like, there's nothing you have to do. It's there, which is like amazing, honestly. And now we want users to test it out and let us know what they're looking for, how it's going, and stuff like that.
Yeah, I should say this is maybe worth calling out just back on table functions real quick is you can write your own table functions as a plugin in Java. So if you really need table functions, like through PTFs, you can make that happen. And there's a couple examples that you could work with. So that's going to require a different set of engineering skills that are probably less common for data engineers. But there's a way down that path if you really need it. But this path is easier for sure. I think I would recommend trying to make it work with Python and with this system a whole lot more. That's simpler, easier, far less headache, and really kind of just works.
Yeah, also, depending on what you're doing, like if you need a table that's, say, no more than a few thousand rows, you could always return like an array and then unnest it. So like you could like an array of struct or an array of row type and then unnest it and do like your table rows would be one way to go. Obviously, like you're limited by how big an array could be. So like say like a few thousand rows is a good rule of thumb, but there are some things you can do.
Okay, so if someone wants to see this in actions, do we have a little demo or should people just go to the docs?
You showed actually everything I was going to show in my demo. So, I mean, I could show that it works, but yeah, it'll be the same as the docs.
I think we believe you, but for those of you that want to play around themselves, so essentially what they would do is fire up the Docker container and then go to the docs. Let me actually like quickly, where's my presentation thingy now? So they could go to the docs and if you go to the example UDFs, this is like a ready baked example that it can run straight out of the box. And that's a super simple test, obviously. And then if you have a catalog that allows storage, then you can even run like this create and then run things. And then these are the same, right? So you can play with those. Is there any more? I think the code base might have some more, right, David?
Yeah, if you look at it's called test Python functions in the code, you'll see a whole lot of examples. Although most of them are actually testing like things like data types, because like you saw that big table of data types, like we had to write tests for all that. So
yeah, cool.
If you want to, yeah, you can see all those in the tests.
All right, I'll put the invite out to everyone out in the community. If you're hacking around with this and you think you got something written up that's cool, let me know and send me a pull request or just let me know via email or on Slack, and I'll try to add it into the documentation. Like we have, I think, in the SQL user-defined functions, we ended up with a pretty good page of like example functions that are like, like doing like really cool stuff, like even a chart, like that's what Jan wrote, for example, or like bunch of date things and stuff like that. So it'd be great to have like little hackery projects like that show a little bit of what can be done with it for all our other Trino community members. So I'll invite you to provide us feedback with that. I also invite you to provide feedback here, and that is we have this blog post, Trino in 2024 and beyond, where we talk about some of the amazing statistics that we shared in Trino Summit. Martin in the keynote talked about that, like, 5,000 additional commits in 1 year when the total commits of 40,000 shows, for example, the massive effort we had on making sure that all the dependencies are up to date and have no security issues and stuff like that. So there's like 225 unique contributors in 2024 is pretty cool, right? Like that shows a pretty wide spread of global adoption and usage everywhere. So I think we can be proud of that. But there's also things we want to know about. So we have this survey here, and I invite you all to answer, like just jump in, let us know what we can do better, how you want to help us with and stuff like that. So please go to the blog post and look at that. It's on trino.io.
Seriously, please fill out the survey. Open source projects struggle with like collecting community metrics, usage ideas, because you can't just like deploy telemetry, because that's not really how open source works. So this is the only way for the Trino maintainer team to know what the hell's going on. So the more people fill out the survey, the more information we have, the better decisions Trino can make to better serve the community. So that is a seriously helpful thing you can do. If you don't contribute to Trino any other way, the survey is the easiest and most impactful way to make the project better. So
yeah, thank you.
And importantly, like telling us what you're using helps us out to make sure that like what you're using gets more attention and love.
Yeah. And then of course we do have, I mentioned earlier already, the Trino contributor call next week. So jump in on that, jump in on Slack. And then on the 30th, we have Mateusz join us to talk about the client protocol improvements, which should be super exciting, and we'll get the demo going for that for sure. It's going to be really cool to see that in action and learn a bit more about like the percentages of like performance improvements he's seen, which I promise you are pretty amazing.
Yeah, the new client protocol stuff is awesome. So that'll be very exciting.
Yeah, no, be cool. So we'll get lots of cool stuff done there. I don't know, David, Cole. I think we covered everything there is to cover today. It's been amazing. What do you want to say?
yeah, thank you, David, for being on the episode. That was really insightful.
Yeah, thanks for having me.
And thank you to everyone who watched. Fill out the survey, and I think we'll see you next time. Yeah.
Yeah, on the 30th, and we had an amazingly competent guest today. You make us all look silly, David. Next time, Mateusz is going to do the same, so it's going to be awesome again. Thank you, everyone.
See ya.
Thank you.